Hi, grade 11s. In this lesson, we are going to look at the nature of roots of quadratic equations. Although this may look difficult to understand, but you'll see with the examples that will follow. With nature of roots, we'll be looking at using b squared minus 4ac. And where does this b squared minus 4ac comes from? You will recall that when you have a quadratic equation that can be written in a format ax squared plus bx plus c equals to 0, we can use the quadratic formula, which is this, to find the roots of that given quadratic equation. And the b squared minus 4ac is what is found under that square root sign. The b squared minus 4ac, which is b squared minus 4ac, we sometimes call it the discriminant. Sometimes you'll find people writing a triangle like that, and they sometimes call it delta. You don't need to worry about that. Let's look at the examples that follows. Suppose we are given this example. They say here, for each of the following graphs, state whether the discriminant is positive, negative, or 0. They want us to say whether the discriminant, or the thing that is under the square root of each of these graphs, is positive, negative, or 0. Now you can see that this graph here, which is a red graph, cuts the x-axis. Then we can say here the discriminant is positive. I can write it in a mathematical way and say the discriminant is greater than 0. If you look at this one here, this graph only touches the x-axis, so we say the discriminant is equal to 0. But if you look at this one, it does not touch or cut the x-axis, so we say the discriminant is less than 0, meaning the discriminant is negative. Now the next question says, discuss the nature of roots of these graphs. So if the discriminant is greater than 0, therefore we say that the roots are real, right? Even here, because touch is there, so we say the roots are real. But here, the graph doesn't cut the x-axis, so we say the roots are not real. Okay? Now, if you look at these ones where they are real, but here you can see that there are two unequal roots, right? They are not equal because cuts there and cuts there. There's a number and another number. So we can say the roots are real. They are also not equal. But in this case, if it touches there, we say the roots are also equal. With the non-real roots, you don't need to worry about them. Let's continue with another example. That example says, without solving the equation, now in this case we must not solve the equation, we must discuss the nature of roots. Alright, so this is an equation, but for the quadratics we must always remember that you must write them in as equal to 0 on the right hand side in this case. So I have 2x squared minus 3x, take a 5 across, is minus 5 is equal to 0. We can do the same thing here and say 2x squared minus 3x and minus 4 is equal to 0. So I've got the equation in standard form. Now how do I discuss the nature of roots without solving this equation? I'm not supposed to. I must use the discriminant. Now the discriminant is b squared minus 4ac, right? We need to find out what is b squared minus 4ac on this thing here. Note that in this equation, a is equal to 2, b is equal to minus 3, and c is equal to minus 5. So if b squared minus 4ac, we are looking for it. The b is minus 3, which is squared, minus 4 times the a, and the a value is set to as 2, and the c value times c, which is a minus 5. When we simplify this, if you don't want to make mistakes, remember you can use your calculator and say it's a minus 3, which is squared, and then minus 4, which is multiplied by 2, and also multiplied by a negative 5. And then what do you get? You get 49. We get the answer here is 49. Let's stop there for now. Let's come to this one. the b squared minus 4ac, we want to find what it is. So the a value is a 2, the b value is a minus 3, the c value is a minus 4. Plug it in. So b is a minus 3, which is squared, minus 4 times the a value, which is 2, and the c value, which is a minus 4. So this gives us, if I put in a calculator to find out what's the answer, calculator says a minus 3, which is squared, minus a 4 times a 2 times a minus 4. What is my answer? The answer is 41. So I've got an answer of 41. Now, I've got to discuss the roots. Now we can see that the discriminant is 49. Let's check. The discriminant is 49 here. The discriminant is 41 here. Now, what's the difference? Because this is a positive number, so we can say the roots are real, and we also know that they are not equal. Same thing here. We say the roots are real, and we also know that they are not equal. But there's something special about this. If you look at this number is a perfect square. This one is a perfect square because I can square root it. It's a perfect square. Alright? If it's a perfect square, then we say the roots are rational. How do I know it's a perfect square? Because 49 can be written as a 7 squared. But if you look at this one, it's not a perfect square. Therefore, we can't say the roots are rational. So in this case, the roots are irrational. Okay? Let's look at another example. A nice one. They say in example 3, x squared minus 7x plus k is equal to 0 has equal roots. So they are telling us that this thing has got equal roots. And we know when we have equal roots that the discriminant is equal to 0. We know that b squared minus 4ac is equal to 0. We know that. Now they want us to find the value of k. Aha! So we say they know that b squared minus 4ac is equal to 0 because they told us. So what is the b value in this? In this case, we know that the b is minus a 7. So minus a 7, which is squared, minus 4 times the a value, which is 1, times the c, which is value is k, is equal to 0. They said from this thing we must find the value of k. If I simplify this, I get 49, and I simplify this, I get a minus a 4k, which is equal to 0. I'm solving for k because it said must find k. I'll take 49 across, so I'll have a minus 4k, which is equal to minus 49. If I divide both sides by minus 4, so I'll get k equals a positive 49 over a 4. That's my answer. K is this. That's what they're asking for. Let's look at this one. This one, they say kx squared minus 4x plus 2 has equals 0 has no real roots. There are no real roots. What are they telling us? They are telling us that the discriminant is less than 0, is negative. No real roots. We said that discriminant is negative. Remember there are no real roots here. The graph does not cut there. It means that the discriminant is less than 0. So therefore, we know in this case that the b squared minus 4ac is less than 0. What is our b in this case? Our b is minus 4, which is squared, minus 4 times the a value, which is a k, times the c value, which is a 2, is less than 0. This gives us 16, and this gives us minus 8k, which is less than 0. They said find the smallest value of k. So you are solving for k. Solve for k, I'll take this to this side. It's minus 8k, which is less than a minus 16. If I divide by a negative number, the sign will change. So the k will be greater than a 2. Now k is a number bigger than 2. But what did they say? They say that k must be an integer. Remember what are integers? They are full numbers, like whole numbers. There are no halves on it. So if you say k is greater than 2, you may include 2.5, 2 and the third, and the 17.5, etc. But we want an integer. What did they say? What is the smallest k integer which is greater than 2? that integer will be 3. Therefore, we can say our value, which is k, will be equal to a 3. Okay? Now, on your own, this is for you to try from your grade 11 Siyavula textbook, chapter 2, just do 2.6 on nature of roots, exercise 2.7. You'll enjoy these problems. They are so nice. Good luck.